Hey everyone, my name is Carell, and today we're going to start getting into the nuts and bolts of the advanced cannon system. We're going to start looking at the actual shells. First though, we've got a few housekeeping items. You really want to design your shells before you build your cannons. Your shell design is going to heavily influence your cannon design, because until the shell is designed, you don't know what your cannon needs to do with that shell. So usually you're going to want to build out your APS ammo customizer here. You're going to want to hit Q on that, and you're going to want to design a shell before you even attempt to actually build a cannon to use this shell. Second, there's a bunch of optimization considerations that we need to look at when we're talking about cannons. We need to look at the rate of fire. A faster rate of fire will generally give you a more consistent amount of DPS, whereas a slower rate of fire will generally give you a kind of burst fire weapon that will hit really, really hard infrequently, which means that misses hurt you a lot more. Second, we also have to consider the cannon's volume. The cannon volume, rather, that is the amount of components in here, kind of the overall size of the build-out of the cannon. A larger cannon is going to have a higher damage and a faster fire rate, generally speaking, but it's also going to be a lot more expensive. It's going to cost you more to armor that, and you get sublinear returns out of continuing to add components generally. So you're never going to get the most optimal cannon setup out of just packing more and more and more components onto a single cannon. At some point, you're going to be better off splitting it into two cannons instead. Third, we have cost. Railguns are great, for instance. They are actually, in this patch, they are amazing. They've got a lot of advantages, and you generally want to mix some railgun into every cannon you create. However, railguns cost energy, and the railgun components themselves are very expensive and fragile. They also tend to be fairly bulky, so again, you're paying more for armor, you're paying more for the components, which means that you're paying a lot more for the cannon as a whole. Fourth, looking at our shell interface, there are a number of components in the parts list that are length limited. Length limiting is sort of like the missiles, where you have a partial component that takes up part of the space. But in this case, it is an entire part in this list that has a length limit associated with it. Those components generally go better on larger caliber shells, simply because they do not take up the full slot. So a larger caliber shell there and a longer shell is going to make that length limited component relatively less impactful to the overall shell design and reload time than a small component will, or a length limited component will, on a small cannon shell. And fifth, you always want to fill out your autoloader. So in this case, let's take this shell. This is basically a horrible shell design that does nothing whatsoever, but in this case we can use it as an optimization. We have a 2-meter shell rack. Generally, you always want to fill out the length of your autoloader. And in order to do that, we're going to need to up the shell diameter, because as the diameter increases, the length of the components also increases correspondingly. So I need to boost the shell diameter here, and right about at the, let's get this up to 333 millimeter. This shell then exactly fits into this 2-meter shell rack. Now what that means is I have the ability to, instead of this 4-meter autoloader here, I can put a 2-meter autoloader and clip design in here, and that will work absolutely perfectly. The 2-meter autoloader and clips will exactly fit this shell. I am not wasting space in terms of autoloaders on my cannon. My shell is getting as many components as it possibly can, and while that does have some negative effect on reload time, generally speaking, the more components the better, because it lets you do more things, more powerful things, and more interesting things with the shell. The last consideration we really need to look at when we're designing a shell is the number of barrels on a cannon. So right here I've got a single barrel. In fact, let's go ahead and go up to we've got 4 gauge increasers. Let's go up to 8. So this will give us a 500 millimeter shell. And we can, in this second tab of the APS, this is accessed by hitting Q on any component of the gun that it doesn't otherwise have a Q menu. The APS section of this allows me to play with the number of barrels on the gun. And so this is going to affect the caliber of each individual barrel, but that very well might be worth it, because if I have one barrel, I might have a 500 millimeter cannon, but if the cannon shell that I'm building for does not operate best at 500 millimeters, I might be better off adding more barrels. Also, adding more barrels, each barrel cools down individually. So if I have a high cooldown time due to using lots of gunpowder on the shell, then I can kind of negate that and not have to pack in a bunch of coolers by simply adding more barrels and using that lower gauge shell instead. Design considerations aside, there's a ton of information in this UI. Obviously, we have the current parts, we have the selectable parts. The part info box is super handy, and if you have questions about what a part does, definitely look it up in here. And down here we've got shell diameter and rail draw. These are not what they seem. In this designer, at this point, when you have a shell editor, you don't know what type of cannon this is going to be loaded in. So a lot of things like the reload time, the barrel cooldown, all this stuff is base values that can be modified by your actual cannon construction. So in this case, in the shell diameter, I'm not controlling the gauge of the cannon by dragging this slider up and down. What I'm doing is telling the stats window that this cannon shell design is going to be loaded into a cannon of this diameter. So it's going to change the stats of this shell based on the expected shell as it gets loaded into the gun. Now you can, in theory, have a single cannon shell that gets loaded into two different calibers of cannons. Generally speaking, that's not a good idea. You want to purpose build your cannons for each shell, but it can be done. So moving on, the shell diameter is just a statistical view tool. The rail draw is similarly just going to affect the stats of the shell. Now, as I increase rail draw here, you can see this shell at 500 millimeters has a max rail draw of 30,000 energy. And I can drag this up here and it will keep increasing the stats until I go above 30,000, at which point it's going to lock that in place. So I can max this rail draw out, and it's only ever going to give me the amount of rail draw that this specific cannon shell can use on each shot. So it's never going to overinflate the statistics on this window. Alright, so moving quickly through the statistics. First off, we have the expected muzzle velocity. This is the velocity in meters per second, and if you hover over this, it will also tell you the total speed modifier of the shell. There's the firepower per intake here. This tells you a rough estimate of how strong this shell will be. It's not a hard and fast estimate, but this is a generally useful indicator of how strong this specific shell design is. Maximizing this gives you something to work towards a bit. It's not perfect by any means, but it's something. Next is shell power. This is a rough estimate of the exact power, or well, not exact, but a rough estimate of the power level of an individual shell. This does not have anything to do with DPS. This is simply just going to be how much one single shell will do. Next, we have barrel length for base inaccuracy and barrel length for full propellant burn. You always want the full barrel length for full propellant burn on your cannon. This is a must. It is not optional. You definitely want the barrel length for full propellant burn on your cannon because otherwise your gunpowder casings are being wasted. You also have barrel length for base inaccuracy. The base inaccuracy is basically just a reasonable amount of accuracy. You can get more accurate by adding more barrel length. So in this case, I need probably a 9-meter barrel, and that will give me full propellant burn and a bit of extra accuracy that's, pretty reasonably good. The next statistic is the size of shell rack and clips that you'll need for the shell. In this case, we need a 3-meter shell rack for a 3,000 millimeter shell. Yeah, 3,000 millimeters is 3 meters, so it makes sense that we need a 3-meter rack for a 3-meter shell. The 1,500 millimeters without casing is not a particularly useful stat. You can pretty much ignore that. We also have effective time and range. This gives you a general indicator of how far this shell can travel before it will basically slow to a stop and plunge straight down. Next stat is ammo cost. This gives you a total ammo cost for the shell itself. So I need to have at least 450 ammo stored on this vehicle in order to reload one shell. And it gives me an amount of ammo per second per intake. So if I have 4 intakes on this vehicle, I'm going to need 16, probably about 19 ammo per second in order to keep up with the ammo usage of this particular shell design at this gauge. I also have a reload time here, which gives me an approximation of how many rounds per minute I can fire per intake. So again, if there's 4 intakes, I have about 2.4 rounds per minute, which is pretty bad, to be honest. Next is the barrel cooldown. This gives you an estimate of how long a barrel will take to cool down after a shot. This is modified only by gunpowder casings. The more of these you have, at the higher the gauge, the more barrel cooldown you have. Next, you have the maximum rail draw. This shell will be able to use this amount of rail energy per shot, and this is modified by the number of rail casings you have on the shell, but every shell has some amount of possible rail draw. That's usually based on its gauge and its length, but like I said, it can be modified with the rail casings. Next, we have the expected recoil force. This is how much recoil is going to be spat back into the gun, and this stat is going to be countered by the recoil absorbers that you have on the gun. There's a recoil force per second that the gun will estimate for you, and you need to make sure you have at least that much recoil absorption on the gun in order to keep firing accurately. Next, there will be several different, depending on your shell design, amounts of damage and armor piercing. These are based on the types of warheads and the warhead nose cone that you have on the shell. So, your nose cone can modify the type of damage. You can have warhead bodies of several different types on a single shell. It will generally create 2 listings for each of those, one with damage and one with armor piercing. Last here we have a detection range. Obviously a lower detection range is better because the shell will be detected under this range by munition warners, which gives lambs a chance to shoot the shell down. We also have a shell health, which basically just provides some resistance to the shell getting shot down. You want shell health, it's good. With all that out of the way, let's start looking at our components. First off, let's filter by casings, and let's go to the back of the vehicle, or the back of the the back of the shell. We have railgun casings and gunpowder casings. Both of these do more or less the same thing. The railgun casings let you add railgun charge to the cannon shell. Gunpowder casings just explode and propel the shell faster. That's really all these are for. Gunpowder casings affect barrel cooldown. Railgun casings do not. The only other thing that affects railgun casings is you must have battery power on the vehicle in order to fire a large railgun, or any railgun. Railguns draw directly from battery power, so you must have battery power on the vehicle in at least this amount in order to fire a shell at maximum rail draw. So 30,000 energy is no insubstantial amount, and so large caliber railguns can get pretty hefty on the battery power. We can also optimize this a little bit. If we have 3 gunpowder casings at the back of this, we have 3435 max rail draw, and we have a muzzle velocity of 1222 meters a second. If we were to add another railgun casing here, we get 50 more meters per second, we get a lower barrel cooldown, and we only increase the max rail draw by 600. So this basically just gave us a tiny bit more velocity, and we can actually divert some of that towards, say, your accuracy rating for the cannon, and we actually increase the amount of damage we're doing because we're going faster, and we have less cooldown now. So adding railgun to this, while it increased the cost of the cannon, is nothing but a straight benefit. And we can mix our gunpowder and railgun casings in order to optimize the amount of benefit that we get out of that. Moving on, we have some shell components that can only go at the back of the shell. Now, these are components that are limited to the rear of the shell, but they have to still go in front of the casings. The casings always go at the far back of the shell. This is the back of the physical part of the projectile that will be launched by the casings. So the shell rear has 4 different possible components. We have the graviton ram, This basically converts some kinetic damage on the shell into kind of a pushing force that will shove vehicles around. This recently did get nerfed. It was a little crazy before, but you can still disorient vehicles pretty badly by using graviton rams. Due to the amount of force that these can apply, they're very often banned in tournaments. Also just because watching a vehicle get rolled over and over isn't particularly amusing to anyone but the person who's doing the rolling, so very often you'll find these be completely banned in tournaments. Next up we have a base bleeder. These modify a shell's speed. They give it a bit more speed, but they also give it a 35% penalty to inaccuracy. So these make a shell much less accurate, and generally I try and avoid these, but it is a way of adding more shell speed while not adding more casings. So by adding a base bleeder, you're not increasing the amount of rail draw, you're not increasing the barrel cooldown, you're not increasing the barrel length for propellant burn. You're just getting a nice chunk of shell speed at the cost of a little bit of accuracy. You also have the supercavitation base. This lets a shell travel through water and be aimed through water, pretty much as if the water was not there. And the downside to this is that most of your shell payloads are going to drop by 25%. So your explosive, your EMP, and your frag shells are going to get weaker. Now, that does not say anything about kinetic shells. You're going to lose a little bit of damage on kinetic shells just from the minor amount of water slowdown that still exists, but generally if you're using a supercavitation base, you're going to be best off with some sort of a kinetic round. Last, we have the visible tracer. This makes your shell, well, visible. It kind of creates a glow behind the projectile, and what this does in cannon terms, this will give you a instant increase to accuracy that decays over time. However, it also makes the shell much more visible. If I was to add one of these on here, we actually lost some detection range because this is a partial component, and that actually made the shell smaller, but on a large gauge shell, this would make the detection range actually considerably higher, and that would allow the shell to be shot down much more easily. It's also not a particularly durable component, so yeah, take it or leave it. If you need the accuracy, it's there. If you don't, well, there's the base bleeder. Also worth noting about all of these shell rear components, they generally will have some modification to the detection range. The visible tracer is by far the most noticeable of those, but the others will have some effect on that as well. Alright, moving on to the shell middles. These are the components that generally make up the bulk of your shell. These usually include most of your damage warheads and a few utility components here and there, but by and large these are concentrated on your damage. First off, we've got a frag warhead body. You're familiar with these from missiles. They create frag particles. That's really it. There's the solid warhead body. This adds a bunch of kinetic damage and a bit of AP. It also gives you a speed modifier of 1.1, so it makes the shell faster overall just by having these somewhere on the shell. Next up is the sabot warhead body. This gives you a lot of AP damage and a little bit of kinetic damage, but really what it's there for, it also gives you some speed modifier. Really what this is there for is punching through really heavy armor. Please note, having this on your shell, anywhere on the shell, anything that says sabot on it, will reduce your explosive damage to 25% of its original value. It's a 75% reduction. Avoid this if you are using any sort of explosives, HE or Flak. Speaking of HE, the HE warhead body is kind of the gold standard. It's kind of what everything else tends to be compared to. This basically has no armor pierce on it. It creates an explosion on detonation. It's like the HE warhead on a missile. However, there are several components in the shell nose section that we'll get into shortly, and one in the shell middles that affect what the warhead body can do, or the HE warhead body can do. So be a little careful how you use these, but they have their place. In fact, they have rather a lot of places. Please note, however, that these also weaken the shell as far as its health. So if this shell is going to be detectable from a long range, maybe you're best off not shooting this at something with lambs. These shells can be shot down fairly easily if you have a lot of HE warheads on them. Moving on, we have the grav compensator, or gravity compensator, and what this does is it makes the shell behave like there is gravity at any altitude, and the gravity strength will always stay the same. So if you're firing a shell that arcs up into space and back down, well, the grav compensator is going to do you a lot of good, because it's basically just going to keep your AI able to aim. AI cannot compensate for the lack of gravity as you go up in altitude. This means that it doesn't have to. Next, we have the Flak warhead. This is very similar to the HE warhead body. However, it does a lot less damage, and it has a way bigger explosion radius. That makes it excellent for an anti-missile system. It also means that this is excellent at stripping off weak, low-armored components on the outside of vehicles. The explosion radius is going to be enormous, so you can bet that the shell itself is going to be relatively near some sort of squishy component somewhere when it goes off. And what that means is your flak is not really going to have to do a whole lot of damage in order to cause some sort of damage to critical systems somewhere on the vehicle. A pure block of armor, a pure brick of armor, cannot fly effectively because it can't detect anything. So a flak warhead means that if you don't have something that's a pure brick of armor, the flak is going to go off and shred something off the outside that's probably going to be important. So they have their place. They are not necessarily as commonly used as HE warheads, but you're still going to find a lot of uses for these. Next in line, we have the smoke warhead. The smoke warhead, well, emits smoke. Now you can see here it will only release a cloud of smoke if the cannon shell has a gauge of at least 200 millimeters. So you have to have at least a 200 millimeter shell in order for this warhead to do anything. Don't even bother otherwise. It has low health, it has low armor pierce, just generally not a very good component for damaging shells at all. However, this can really mess with opponents. You can have a smoke warhead that, or smoke cannon that fires smoke and uses a time fuse to detonate that just a short distance in front of your vehicle so that you're always flying through smoke. That makes enemy laser vehicles and laser detection pretty much a non-issue. You can also have smoke hit an enemy vehicle, and you can really mess with their laser-guided missiles. You can mess with their laser detection, with their anti-missile lasers. You can just completely devastate an enemy by proper use of smoke. However, it's not always effective against all types of vehicles, so not always your best component option. Moving on, we have inertial fuses. These, basically, if your shell would change angle at any point in its flight path suddenly and above a specific threshold, this shell will detonate. Now, detonation is completely useless for kinetic shells, very useful for frag, HE, and flak. So inertial fuses are generally used with one of those three options, but yeah, you can make an argument for EMP warheads as well. But yeah, other than those component options, don't use these. These are also fairly fragile, but they are limited to a maximum part length of 100 millimeters. So at least you aren't using up a full component, on like a 500 millimeter shell, you're not using up a full 500 mil on just a fuse. Similarly, we have the proximity fuse. This basically tells the shell to explode if it gets within a certain distance of the target. Again, that's pretty much only useful for frag and HE and flak, and of those three, HE is still not a good option because detonating anywhere but right up against the hull is generally a bad idea. So really you are limited to flak and frag at this point. And of those two, frag is largely going to get deflected by shields, so yeah, flak only, and even then it's not all that great. You're better off with a time fuse or an inertial fuse. Next warhead on the list is the EMP warhead. This does EMP damage. Again, this is electrical damage that travels through any metallic block on a vehicle and will seek out and destroy any electrical components that it can reach. So in order to insulate from this, you have to have non-conductive components or non-conductive armoring or something along those lines to prevent the EMP from getting to your sensitive electronics. Next up, we have the stabilizer fin body. This gives you a little bit of accuracy, actually a fair bit of accuracy, at the expense of 5% of your flight speed. That's really it. You get a little bit less speed, a little bit more accuracy. Good. It's also limited to a maximum of 300 millimeters, so if you want to use this, I would recommend using it on very large shells, just so you're not wasting an entire component slot on it. Next in line, we have the altitude fuse. We looked at this, the fusing for this, when we did the cannon construction tutorial. Basically, I don't like these all that much. You can have a shell explode above or below a specific altitude. There's better options. If you're using this, you're probably going to want to look at doing something else. The timed fuse, however, is super useful. Timed fuses are great for anything that's going to involve a shell detonating near missiles or for flak. Sometimes these are useful on 360-degree frag, but usually timed fuses are going to be used with a flak warhead. Not a whole lot of use for them otherwise, but timed fuses with flak warheads are great for anti-missile and anti-light aircraft. Next we have the penetration depth fuse. This is great if you're trying to build a shell that tries to punch through an enemy's outer hull and then explode inside the internals of the vehicle. So using this, you can get an HE shell or a flak shell or a frag shell into an enemy's guts and then set it off. And yeah, it would be a great tool if you're trying to build something that does that. However, there's other options if you're just trying to deal basic internal damage. So pen depth fuse, little situational, but it has its place. Next is the emergency ejection diffuser. This, if you have a shell ejector on your autoloaders, will defuse the shells as they're ejected. So if you have a bunch of HE shells in a really compact cannon and you're trying to eject them, the emergency ejection diffuser will ensure that those shells never detonate if they're ejected. So it makes those shells totally inert once they're ejected, and means that you can build even the most explosive cannon imaginable and not have it detonate when it's damaged. It also has a max part length of 100 millimeters and no other properties, so this is actually a super good component if you're building large shells. Last, we have the shaped charge secondary, and this will basically convert any HE warheads behind it, as well as providing a bit of a high explosive damage itself, into a heat charge that will deal damage to internals of vehicles by kind of sending a bunch of particles through the armor without really attempting to damage the armor itself. So this is not quite as effective as a heat nose cone or shaped charge nose cone, but it's there. So it can be useful if you're trying to do something like a hollow point shell that hits a target, blows a hole in the armor, and then tries to jet some particles into the inside of the vehicle as well. Last, we're going to start going through the shell and nose components, and we're going to move pretty quickly through some of these. We have the HE, the frag, the EMP, and the flak head, and these are all exactly the same as their warhead body components. They just give you a little bit of speed modifier on the top as well. So they give you a little bit of speed, more than just another warhead body would, and they just contain, a shell or warhead of the appropriate type. Next, we have the Disruptor conduit. The Disruptor conduit basically takes EMP warheads that are on this and will channel those into any shield that it comes in contact with. So it will channel these into the shield blocks directly, which means that if you have a shield block and you on a target vehicle and you fire a disruptor into it, suddenly the target vehicle no longer has a shield in that location because the shield block has been blown off. That is super, super useful, but disruptor conduits reduce the strength of all payloads on them to 50%. So anything else you put on the shell is not going to be very good. you're better off making a dedicated disruptor conduit cannon and having that as a secondary battery on your vehicle than you are attempting to mix disruptor conduits and any other type of damage. Next up, we have the squash head. The squash head basically nukes all AP on the shell. Don't try and mix this with any sort of solid warhead body or AP damage at all. And instead, this creates what's called a HESH shell. It will convert HE into damage that will attempt to punch through armor. And what that's basically going to do, it will deal a little bit of damage to armor. It'll deal some thump damage. And that can actually deal a fair amount of damage with enough shell size. But really what the strong part of HESH is this will create spalling inside the vehicle based on the innermost armor's armor class. So if this hits armor, it's going to create a bunch of particles inside the vehicle that will deal a ton of damage based on the armor class of the innermost layer of armor. And that means that if you're creating an armor designed to mitigate squash heads, you actually want something like wood or stone as your innermost layer of armor, because it's going to mean that the squash head will deal less damage to the internals. As far as the shell itself, squash heads make you deal a lot of damage to very heavily armored vehicles. They're not going to strip off the armor blocks on the outside of the vehicle, but they're going to shred vehicle internals. Very useful. In that same vein, we have the shaped charge head. We've talked about this a little bit, but more or less what this does is it will attempt to pierce the target vehicle with a jet of copper. That's kind of flavor text. More or less what it's doing is it's going to try and push a bunch of particles through any armor it hits and spawn them on the inside. That's subtly different from the squash head in that this does not rely on the armor class of the innermost layer of armor or whatever block it hits. It's not going to rely on any armor class at all. However, it has to work in order to pierce armor class. So this is better against light to medium armor and to some degree heavy armor. The squash head is good when you're hitting the really super heavy stuff. This is your anti-battleship type of damage head. Also worth noting that your heat AP damage, this is completely independent of the armor struck. The particles are always going to have 6 AP. That's more than enough to kill squishy internal bits. You're not going to deal any damage to armor with this. Don't even think about it. So if you're trying to actually deal armor damage, stick with a squash head. The shaped charge is going to do no good for you. Moving on to kind of an intermediary between the two, we have a hollow point head. This is kind of an unusual head because it means that the shell will always detonate on impact. That means we don't need an inertial fuse, we don't need a pen depth fuse. Neither of those are going to be, well, really any fusing at all is going to be completely useless with this type of head. And this also will only ever have an armor pierce of 10 by default anyway. This can be increased with solid warhead bodies and other tools, but the warhead is, with a hollow point, it's going to take all the kinetic force and kind of ram that into the armor, and just the armor or whatever blocks it hits. And it's going to spread damage out from there and just kind of shatter blocks off the point of impact. So this is excellent at actually destroying chunks of vehicle armor, and if you hit a small vehicle with a medium-sized hollow point shell, it's just going to completely disintegrate. It will just completely evaporate, and it will lose all sorts of critical components. It's great. So hollow points are excellent for just general purpose damage dealing. However, traditional from the depth shields are decently good at deflecting these, and if these are deflected, they will deal 0 damage. You must make impact with the target vehicle's hull in order for a hollow point head to do anything. And as a side note, these are an excellent way of forcing any attached HE, frag, flak, any of those shells or warheads. It's a great way of forcing those to detonate without having to use a fuse. Next, we're going to go over 3 different heads here as a group. We have the heavy head, the armor-piercing head, and the sabot head. The heavy head is a really high kinetic damage modifier. It's a pretty fast shell head, and it has medium amounts of armor piercing. More than any of the AG stuff or anything like hollow point or any of that. Not as much as the other 2 kinetic options. this is still well enough to punch through anything up to light to medium armor. And it adds a ton of kinetic damage, so very useful in just absolutely ramming your fist into that vehicle. The armor pierce head shifts things more in the balance of AP and less towards kinetic. So we're going to deal less kinetic damage. We're going to deal much more armor piercing. So that is good at medium to heavy armor. It's going to deal with any armor that you have really well. The sabot head is a very specialized head that I would only use in very select circumstances because, again, this sets the actual warhead damage of a bunch of different types of warheads to 25%, but this gives you the highest amount of armor pierce. In fact, it gives you an absurd amount of armor piercing. On a 150mm shell, I have nearly 200 armor pierce. That is ridiculous. That is way more than I need, and this will penetrate everything but the absolute heaviest armor with ease. It's just going to blow straight through it. The last component we're going to go over is the skimmer tip. This gives you a 100% chance to skip off the water. You might have seen this effect before. It basically just bounces the shell off the water if the shell is going relatively parallel to the surface of the water. This increases the angle that's valid for that skipping and gives you a 100% chance to skip off the water. Now what that's good for is really just kinetic shells. You're not really going to see a whole lot of HE with this that works real well, but this tip does give you a bunch of extra armor piercing, and it's a very fast nose cone. So this acts sort of like an armor piercing head with a bit less armor piercing, but it's really good for ship-to-ship combat. The downside to this, obviously, is if your target ship is storing their ammo below the waterline, you're never going to hit it if you have a skimmer tip on there. And most ships are going to mount their ammo below the waterline specifically because of skipping. So, yeah, I tend not to like these all that much. Alright, so that's it for today. Next time we're going to start looking at some actual cannon examples and some fairly optimized shells. Again, by no means the only way to do things or even a really great way to do things, but I'm going to show you some of my designs that I like to use and that I've found pretty effective since the APS rework. Thanks for watching. See you next time.